we're going to go through some definitions first and go through the gas laws, and then we will get into the basic refrigeration cycle, and we'll see how that all relates. I know modules 1 and 2 are tough, a lot of formulas, a lot of talk about how many BTUs does it take a 10-pound block of ice at minus 10 degrees and make it into 250 degrees steam, but that's all for a purpose. We'll kind of get into that in just a bit. Okay, the first definition, heat. Now, when you think of heat as a human being, that is like your stove and it's hot and you get burnt. But truly, heat is just a form of energy and it's molecules in motion. So even with an ice cube that's at 32 degrees, there are molecules in that ice that are moving and there's still heat there. It isn't until you get down to minus 460 degrees and all molecular motion stops. And that's never been reached yet. You can get down pretty close to that. But so I want you to start thinking of heat as molecules in motion, not so much as something that is hot to your touch. And heat always flows from a substance that has more heat or more molecules and motions to one with less heat. This will give you a quick example right here. For example, this block of ice at 32 degrees does have molecules in motion, but they're pretty much bonded together and they're not moving very much. They're just sitting here pretty, while they are moving, they are not bouncing into each other too much. They're more or less bound together, and that's why that gives ice its solid form. And as we start to add heat to the ice and it begins to melt, the molecules begin to move a little bit faster. So not only are they bound together, they start to cut loose their binds with each other and turn into a liquid, and